My name is Jeffrey Frankel, and I have shown students techniques to reduce the time answer questions in paper 1 of the IB chemistry exam at both levels, standard level and higher level. These questions are multiple choice. You have 90 seconds available for each question, and you have no calculator. These techniques that I am about to show you will help you dramatically reduce the time needed to answer those questions correctly in maybe 30 or 40 seconds, and in some cases even less, thus giving you extra time to do other questions within the paper.
In this series of paper 1 questions, the examiner is testing for 1 or maybe 2 or 3 concepts. In this particular question, he's testing whether you understand the relationship between a volume of a gas and the numbers in front of the molecules. What he's asking is, do you know that there is a direct relationship between those numbers and this number for ethine and the corresponding number for the volume of oxygen? And the direct relationship is simply, if there are 2 moles of C2H2 and 5 moles of O2, then if you're starting with 0.4 of a decimeter cubed of C2H2, then the final result, the final volume of oxygen, would be 5/2 times 0.4, which equals 1. And so the answer is 1. And that's the kind of thing that can be done in your head. You look at this equation, the examiner asking solely for the volume of oxygen, and the examiner gives you the volume of C2H2. It's a very simple calculation and can be done in your head. This question is very similar to the previous one, with one slight addition to the problem, and that is that the volume of oxygen has to be converted to the volume of air. And clearly, if 2 molecules of SO2 react with 1 molecule of oxygen, then 2 molecules of SO2 will react with 5 moles of air. And that's the change. So we then look at the volume of SO2, which is 10 decimeters cubed, and therefore the amount of air is going to be 10 divided by the 2 multiplied by 5, and that equals 25, and therefore the answer is D. Again, this is something you can do in your head. You don't need to write anything down. You can see it quite quickly, and it should be something that you can do within 20 or 30 seconds, thus saving you a minute to do other types of questions later on in the paper. In this question, the examiner is again asking you if you can see the relationship between the volume of gases, that and that, and the equation, the complete balanced equation. Can you see that relationship? And secondly, he's asking you something else. Do you realize that there is a limiting reagent? And in general, if the examiner gives you the volume of that reagent and the volume of this reagent, in other words, if he gives you 2 volumes for 2 reagents in the 2 reactants in the reaction, then there is a very good chance that one of these, either that one or that one, is a limiting reagent, and you have to find that out. So let's go to the equation. If we have 3 decimeter cubed of C2H2, we're going to need 6 decimeter cubed of hydrogen. We don't have 6 decimeter cubed of hydrogen, we only have 3. Therefore, hydrogen is the limiting reagent, the limiting reactant. And therefore the amount of ethane formed is going to be dependent solely on the volume of hydrogen. The ethane is irrelevant, forget it. So we look at the hydrogen. We can see that 2 moles of hydrogen gives 1 mole of ethane, therefore 3 decimeters cubed of hydrogen will give 1.5 decimeters cubed of ethane. And therefore we put A as the answer. Okay. Interestingly enough, there's all these words down here, assuming the reaction goes to completion, all gas volumes are measured at the same temperature and pressure. Irrelevant. In general, with most of these questions, you assume that the reaction goes to completion unless they say otherwise. And again, you assume volumes are measured at the same temperature and pressure unless they say otherwise. So all of this is there to, shall we say, slow you down, maybe confuse you, but it's all irrelevant. The important thing is, what is the question? What volume of ethane is formed? And the second thing is that if they give you 2 volumes for the 2 different reactants, you've got to realize there is a limiting reagent. One of them is a limiting reagent. This one you should be able to do in 10 seconds. If you can't do this in 10 seconds, if you can't see the answer within 10 seconds, then you need to practice a lot of these. 10 seconds is as much as you need. Essentially they're asking, what's the amount in moles carbon dioxide formed by the complete combustion of 3 moles of butane? The equation tells you 2 moles of butane gives 8 moles of carbon dioxide. Therefore, 3 moles of butane will give you 12 moles of carbon dioxide. The answer is C, 12. If you find difficulty with this one, I suggest you do a lot of these kind of examples. Find as many as you can. Go through this video again and again until you can see that this can be done in 10 seconds. As I mentioned earlier, if they tell you the amount of both reactants, 2 moles of carbon dioxide, 3 moles of hydrogen, there is a very good chance one of them is a limiting reagent or limiting reactant, and you have to find that one. So let's look at it. 2 moles of carbon dioxide would need 6 moles of hydrogen. We don't have 6 moles of hydrogen, we only have 3 moles of hydrogen. Therefore, hydrogen is the limiting reactant, and the amount of methanol that can be formed is determined solely by the hydrogen. So we have 3 moles of hydrogen, which is actually the same in the equation, 3 there, and therefore it will produce only 1 mole of methanol. So here we have the answer A. Again, this is something that if you have difficulty understanding this, if it takes you more than 10 seconds to deal with this one, I suggest you do a lot of practice with these, because these are the easy ones at the beginning of the paper, and it is expected that you will save time on these ones so that when you come to the questions towards the middle and end of the paper, paper 1 we're talking about, you will have more time for them. In this question, the examiner has thrown at you an equation which you've probably never seen before, and it may look horrific. However, you have to see that there are some interesting aspects. And the first one is that they tell you the number of moles of chloroethene and the number of moles of oxygen. Therefore, one of them is a limiting reagent, limiting reactant, and it's important to find which one. So if there were 10 moles of C2H3Cl, then we're clearly going to need 5 times that of oxygen. That's 25 moles of oxygen. Actually, we've only got 10 moles of oxygen. Therefore, the oxygen is the limiting reactant in this case. And so when you're asked to determine the amount in moles of water produced, you only need to look at the amount of oxygen you've got. You've got 10 moles of oxygen, which is twice that. Therefore, you look at the water, and you're going to get twice that amount of water, and it must be 4. And again, this is one which is relatively easy. Maybe it should take you 30 seconds, but certainly not more. Many students, after they've looked at this one, think they have to work out the equation for the burning of propane in air. That is not necessary, but you do need to know the formula of propane. So let's write that down. C3H8. You need to know that. And immediately you see that, you realize that those hydrogen atoms, those 8 of them, are going to form the water. And they can only form 4 moles of water. 8 hydrogen atoms can only form 4 moles of water. Therefore, the only 2 you're looking at is C and D. You can ignore A and B immediately. Then we look at the carbon atoms. There are 3 carbon atoms. Now, each carbon atom requires 1 mole of oxygen. 3 carbon atoms require 3 moles of oxygen. You may think, oh, it must be C, but of course it's not C because the hydrogen requires oxygen as well. Therefore, the moles of oxygen needed is going to be greater than 3. The only possibility they give you is 5. So that without calculating it, you know that the answer must be D. Thank you for watching. If you found this YouTube video helpful, please see my other YouTube videos. Thank you.